Now this is a quite good problem. So we have to identify the given compounds. So question says W and X are optically active isomer of. So we have two compounds W and X, and they are isomers and optically active isomers. So they are optically active isomers. Optically active isomers. And the question also gives the molecular formula. So it says C5H9Cl. So this is the compound W and X. And our next part of the question says W on treatment with 1 mole of hydrogen. So I have W, and W is treated with 1 mole of hydrogen. So this time there will be something like double bond. 1 mole of hydrogen is converted to optically inactive compound bi. So now this gives bi, and that is optically inactive. So this becomes optically inactive. So if I add 1 mole of hydrogen, then this becomes optically inactive. This means what? This means there are two groups that is attached to the same carbon, have same kind of group, only difference is the difference of a double bond. We'll discuss. But compound X gives an optically active compound Z under the same condition. So if you have X and you add 1 mole of hydrogen with X, this gives compound Z that is optically active. So Z is optically active. Are you getting? Now question says give the structure of Y and configuration of W, and also draw the feature projection formula of X and Z. So you have to give me the structure of X and Z and Y as well as W also. So I will give you 1 minute time. Let me see how many of you can do. And the hint is, if I add 1 mole of hydrogen, this becomes optically inactive. This means there are two groups that is attached to the W, has same kind of thing. So let us wait for 1 minute. Okay, let us see. You have compound C5H9Cl. How many unsaturation factors? So you have unsaturation factor in this case is, so you have 5 carbon, so you should have 5 into 2, 10 plus 2, 12 hydrogen. But you have only 9 plus 1 in case of unsaturation. Chlorine will be treated as hydrogen. So you will have 10 hydrogen divided by 2. So unsaturation factor is 1. So we have 1 unsaturation factor. This means this indicates W and X both contains 1 double bond. So now I know W and X both contains a double bond. Are you getting? Now the question is, you have 5 carbon. So you have compound is 5 carbon. So 1, 2, 3, 4, 5. Let us try to see if you have 5 carbon and compound is optically active. So how can I do is, so let us make this is, and this side I can put a hydrogen. So you can think, so this side is a hydrogen. Now this becomes optically inactive. This is possible only if there are two groups that is attached same kind of group, and in one case there is a double bond. So this should be W. Are you getting? So W will be this. And if you add 1 mole of hydrogen, what you will have? This compound. So this carbon is a chiral carbon. because you have Cl, H, and this side is a different group, this side is a different group. Now if you add 1 mole of hydrogen, this becomes ClH, and this side Cc. Now this carbon is not chiral carbon, so this is not a chiral carbon because this side ethyl group, this side also a CH2CH3 group, ethyl group, not a chiral carbon. So this means optically inactive. Are you getting? So this is W and this is your compound bi. So we have deduced the structure of W and bi. Now the compound X, that is basically isomer of W. So what are the possibility? And this compound is also optically active. So compound X is also optically active. So can you think what should be the structure of X? So it is given compound X does not lose its optical activity. So this becomes optical active after the addition of 1 mole of hydrogen. This means, can I try something like this? So I should have two different kind of group, Cl hydrogen, Cc. So I will have two different kind of groups. So this side you have 3 carbon and this side you have 1 carbon. So two different. So this group, that is CH3 group, and this side you have propyl group. So even if you have a double bond, are you getting? So this, even if you have a double bond, if you add hydrogen, this compound will remain optically active. Are you getting or not? Now basically we have two options for double bond. I can put a double bond here or I can put a double bond here. So anyone you can take. So let us put a double bond here. And if you do hydrogenation, you will have C, Cl, hydrogen and carbon. So this is your compound after the addition of 1 mole of hydrogen. So this is compound Z, and that is basically optically active because this carbon is still a chiral carbon. So this is optically active. You can also have a situation, so there are two possible structure of X. You can have a double bond here also. Can you think some more possible structure of X? Basically there is one more possible structure of X. So this is one possibility for X. So we can draw one more possibility. You can have something like this. So let me see. So we have been given you two possibilities. The third possibility is you have carbon and then let us say you have CH2Cl. And you make this carbon chiral by putting one CH3 group this side, put one hydrogen this side. So you need 5 carbon, 1, 2, 3. We have already engaged 3 carbon. Now we need 2 carbon. So let us put something like this. That is CH2CH. Now this carbon is still a chiral carbon because they contains 4 different groups. Now if you do hydrogenation, you still have a compound that is optically active because this carbon will contain CH3 hydrogen, and this side you will have CH2Cl, and this side you will have CH2CH3, that is ET group. Are you getting? So you have 1, 2, 3, 4, 5 carbon. So this is still optically active. Are you getting or not? So this means there are two possibilities for X. Not only two, we have 3 possibilities. So this is X and this is your Z, that is the product after reduction. So you have 3 possibilities. One, if you see your copy, you will find you have one is this Cl, C double bond, C and C, and then you have hydrogen here. This is one possibility for X. Are you getting or not? Another possibility, you can have a double bond here. So you will have C double bond C, Cl, CH. So in this case this is a chiral carbon. In this case still it is a chiral carbon. So this is a possibility for X. And the one possibility we have written just above. So this one. So you can have. So you will have CH2 double bond, CH, CCH3, and then you will have CH2Cl, and then you have hydrogen. Are you getting? So this is another possibility. So let me put CH3 here, and this is CH2, and this is CH, and this is CH2. So these are the possibility you have. In this case, this is the carbon that is optically active. So we have three possibility for X. So there are three possibility. So there are three possibility for X. Similarly, we'll have three possibility for Y. So after reduction, you will get this compound, and after reduction, you will have something different compound in this case. Are you getting on? So we'll have three possibility. Okay, let us discuss the next problem. I think all of you are able to understand this one. You may think there may be possibility of some more, but for me, as long as I can understand, there are three possibility for X. You can exercise yourself. If you find more possibility, that is also fine. Okay, let us discuss the next problem.